Hello students, I hope you are having a wonderful day. Let us continue with module number 9 of our R.C.C. And in this module I am going to start first chapter, you can say chapter number 3, which is singly reinforced rectangular section. In the next chapter I will teach you double reinforced rectangular sections. Sir, a single reinforced, double reinforced क्या है? As I have explained earlier, whenever you are loading any concrete structure, because of this loading, top layer में क्या रहेगा? Compression रहेगा, and bottom layer you will be having tension. If you are loading something like this, obviously top layer you will be having compression, bottom layer you will be having tension, right? Because I have taught you, right? So clearly in the last module I have taught you it will be something like this. Whenever you are applying the load, it will be bending into something like this. Clearly you can see the top layer is under compression, it got compressed, and the bottom layer you can see it got stretched. Yani it got some tensile forces in it. I hope it is very clear for you because of this loading. So I have told you concrete is good in compression, right? FC के जो भी मिलता है, it is characteristic compressive strength of concrete. But concrete is weak in what? It is weak in tension. Tension नहीं ले सकता है concrete. It has very less tensile force. Hardly 1/7 to 1/10 of compressive force only it has. So obviously to take this tensile forces, what we are doing? We are keeping this reinforcement bars. We are keeping some reinforcement. It could be anything. It could be even bamboo. It could be aluminium. कुछ भी रख सकते हो, but basically हम कौन सा प्रीफर करते हैं? स्टील प्रीफर करते हैं. There are a lot of advantages of using steel. I have already taught you in the very first module. So something like this you will be having. If you are having some beam, आपका reinforcement कुछ इस तरह से रहेगा. We can't draw like this always, right? That's why what we are representing something like this. We are representing something like this. Okay, so these circular dots represents my circular bars, my steel bars. I hope it is very clear. So if you are giving the steel bars only in tensile zone, I will be calling it as singly reinforced rectangular section. ये क्या हो जाएगा? Singly reinforced rectangular section. Because it is reinforced at only tension zone, I am calling it as singly reinforced. But if I really want to decrease the dimensions of this, okay, if I want to make it very small, I want to make the dimensions less, what I can do is, or in some cases we have to provide more steel also, and bottom layer में आप provide नहीं कर सकते हो. In that case, or if you want to wantedly decrease the size of your beam, what you can do is, in compression zone also we will be providing steel. ठीक है? Why we will be providing, how we will be providing, we will study in next chapter. This will be calling as, obviously, what should you name it? Doubly reinforced rectangular section. But now, for now, what in this chapter what we are studying? We are studying singly reinforced rectangular section. I hope concept is clear for you, right? So there are again three types of sections possible based on amount of steel. AST. What is AST means? ST means steel. ST का मतलब है steel. A area. So AST means area of steel. So based on this area of steel, I can divide this section into three categories. One हो गया balanced section. What is the first one? Balanced section. The second one is under reinforced section. Third one, over reinforced section. ठीक है? So there are three sections possible based on amount of steel. The first one is balanced, second one under reinforced, third one over reinforced. Super important bit for your SSC JEE, any examination, especially small examinations में direct bit पूछा जा सकता है. So you can't expect this silly questions in GATE, but ESC multiple choice में पूछा जा सकता है. SSC JEE, state PSC, this could be a hot favorite. So let us try to understand what are these three sections. Okay, based on amount of steel, how we are getting these three sections, let us try to understand. First one is balanced section. Okay, I will teach you in notes also, but let me give you a brief introduction so that you can understand easily. Okay, so first let us see balanced section. In balanced section, so you are providing enough amount of steel so that the maximum stress of concrete and steel is reached simultaneously. See, I have told you a very important concept in the last module in assumptions of limit state method, that my strain is linearly varying. याद है ना आपको? What is my strain? My strain is linearly varying. To get the maximum stress possible, what should be the strain value? Strain value भी maximum रहना चाहिए. Common sense की बात है. So where will be the maximum strain? Obviously in the top layer you will be having maximum strain. इस डायग्राम ने मैंने आपको बता दिया था ना. Let us try to understand. If this is your beam, you are loading, so obviously because of the load वो कुछ इस तरह से bend होगा, वो कुछ इस तरह से bend होगा. Agreed or not? So you can clearly see if this I am calling it as neutral axis. Maximum strain कहाँ पे है? यहाँ पे है ना. It moved more extent. It is nothing but deformation. What is strain? Deformation divided by original length. You can clearly see deformation कहाँ पे ज़्यादा है? It is maximum at the topmost layer. So compressive this whatever maximum strain we have, we will be getting at the top layer only. Common sense की बात है. How much is it? I have taught you in the last module. In the assumptions itself, what is the maximum compressive strength possible in concrete? 0.0035. So this much amount of strain will be present. So simultaneously, we should also get strain corresponding to maximum stress. What is the maximum stress possible in my steel? That will be obviously F5, but इतना नहीं लेंगे because we are designing as per our limit state method. We have to divide this F5 by partial factor of safety. Steel का कितना 1.15, so you can write it as 1.87 F5. So I have to strain it up to the stress of 0.87 F5. So how much is the strain? How much will be the strain? Common sense की बात है. If you are talking about Fe 250 mild steel bar, as I have explained you earlier, उसका कर्व कुछ इस तरह से रहेगा ना, something like this, and this is your ES value up to the yield strength. I hope you remember this simple concepts from the last module. So if you want strain, how you will be getting? You will be getting ES is equals to stress divided by strain. So if you want strain, just divide stress divided by ES. How much is the stress? 0.87 F5 divided by ES. What is ES value for steel? 2 into 10 to the power of 5. So this much will be your strain. If you are talking about Fe 250 substitute kar lena, how much you will be getting? 0.00108. So this amount of strain should be reached in my steel bars. If you are talking about something HYSD, okay, हाई यील्ड स्टील के बारे में बात कर रहे हो, वी हैव टू ऐड दिस 0.87 F5 by ES by proof strain value. Proof strain value कितना? 0.002. So this will be that. If you are substituting this F5 as 415, you will be getting how much? 0.0038. And if you are substituting 500 in place of F5, you will be getting 0.0042 as your maximum, as your minimum strain which should be present, as your minimum strain which should be present to give you this much amount of stress. 0.87 F5 corresponding stress चाहिए तो इतना strain तो रहना ही चाहिए. I hope it is very clear for you. So what I am doing is, just let us try to understand. We are getting maximum strain here, and corresponding to that we are getting the strain value which is giving this much amount of stress, 0.87 F5, which is as per Fe 250 0.00108, as per Fe 415 it is 0.0038, or as per Fe 500 it is 0.0042. डायरेक्ट नंबर से याद रखने की जरूरत नहीं है. You have to remember like this: 0.002 plus 0.87 F5 by ES. This much amount of strain is reached. If both of these strain values, this much amount of strain 1 and this much amount of strain 2 is reached simultaneously, okay, you are loading and the maximum strain is reached in your compressive zone, and the minimum strain, I am calling it as minimum strain because I have explained in the last module, right? Minimum itna rehna chahiye to get this much amount of stress. My curve will be something like this. Even how much strain I am going to add, it doesn't matter. After this value of 0.002 plus 0.87 Fi by ES, my stress corresponding will be 0.87 Fi only. So minimum अगर इतना तो strain आपके body में है, then we will be calling it as balance section. Okay, you are loading such that we are getting 0.0035 and 0.002 plus 0.87 Fi by ES simultaneously, then I will be calling it as balance section. Clear concept? Okay, and use your common sense. In the last module I have taught you XU limited value, right? Neutral axis ka limited depth. Okay, so what is the maximum it can have? It can have 0.53D for Fe250, 0.48D for Fe415 and 0.46D for Fe500. I have told you to make a table in your short notes, right? Because this is a very important bit. infinite number of small examinations, SSC, JE, or you can say state PSC. This was asked so many times. Okay, so XU limit value for your FE415. There will be 4 options. You have to take 0.48D. You will be getting your 1 mark. ठीक है, so your neutral axis का limiting depth कितना रहता है 0.48D for FE415 and 0.460 for FE500. Right, how you got these values? We have assumed it as balanced section only. हमने जो कैलकुलेशन किया था, I hope you remember it, right? We have assumed यहाँ पे 0.0035 था, यहाँ पे 0.002 plus 0.87 FI by ES था, and using similar triangles I just find out the depth where there is no compression and no tension, and I got my XU limit value. So this is nothing but your balanced section, baba. In balanced section your XU value is nothing but XU limit. Okay, your depth of neutral axis from compression zone, the maximum compression zone, is your XU limit itself, which is 0.53D, 0.48D and 0.46D. Concept समझने आ गया? Perfect है अब. This is balance section. Now let us try to understand what is under reinforced and what is over reinforced. So let us say in balance section my AST it came to be, let us take some 650 mm square. अगर आप इतना स्टील प्रोवाइड करते हो in my body, okay, in my body, if you are providing this much amount of steel 650 mm square, I am just giving you a rough number, okay, just for example, then I will be getting this 0.0035 wala, 0.0035 wala, and simultaneously I am also getting this much amount of strain, the minimum strain whatever should be present, 0.002 plus 0.87 Fi by ES, this much amount of strain and this much simultaneously I am getting. So if I am providing more steel than this, okay, if I am providing more steel than this condition, should I call it as over reinforced or under reinforced? If you are providing something more, what will you call? Use your common sense. We will be calling it as over reinforced. If I am providing the steel more than 650 mm square in this example, I will be calling that same whatever section hai, but the amount of steel is more, I am calling it as over reinforced. Here if I am providing less steel compared to my balanced section, let us say some 600 मैंने provide कर दिया, ठीक है. If I am providing anything less than 650 mm square, then should I call it as under reinforced or over reinforced? I am providing less, so obviously I will call it as under reinforced. यानी कम reinforcement है. Over reinforcement ज़्यादा reinforcement है. That means more steel is provided. Under reinforcement less steel is provided. Common sense की बात है. I hope you got it right. How silly is this topic? If you are providing steel less than your balance section, under reinforced. If you are providing steel more than your balance section, over reinforced. समझ में आ गया concept? Let me make it very clear. As per limit state method, which structure you should design? Balanced, under reinforced, or over reinforced? Which section you have to design? It could be asked as a bit. So what is your answer? Your answer is under reinforced. Always remember, as per limit state method, we should design our under reinforced structure only. Okay, हमेशा under reinforced structure ही देना है. क्यों देना है? Let us try to understand. If you are giving less amount of steel, as I have explained you earlier in earlier modules, if the amount of steel you are providing is less than your balanced section, then obviously let us try to understand. You have some structure like this. This is AST, ठीक है. So you have more area and you are applying certain amount of force. So the strain value will be less. But if you are providing lesser area, ठीक है, lesser area of steel and for same amount of force, then obviously your strain value will be more. Common sense की बात है, right? Common sense की बात है. If you are having some bulky object and कुछ force लगाना, थोड़ा ही extend होगा. If you are applying कम एरिया वाला ऑब्जेक्ट एंड अप्लाई द सेम अमाउंट ऑफ फोर्स, इट विल एक्सटेंड टू अ लार्जर डायमेंशन. कॉमन सेंस की बात है, राइट? द सेम कॉन्सेप्ट इज अप्लाइड हियर. सो the elongation or you can say the deformation is more if you are taking less amount of steel. So let us try to understand, whenever you are applying this load, so this steel bars will be deforming more. If you have more deformation, then you can clearly see अगर load कुछ ज़्यादा हो गया है तो आपका beam deformation देगा. Seeing the deformation, you will be knowing something is wrong with this structure. Okay, before it collapses he will vacate that building and no loss of life will occur. समझ में आ रहा है ना concept? But let us try to understand. If you are providing more amount of steel, if you are providing more amount of steel now, so what is happening? Obviously its deformation is less, so the deflection will also be less, right? The deflection will also be less. तो कोई deformation नहीं दे रहा है, you cannot see anything. When the load is more, obviously steel, because of steel it is safe, but ये जो concrete है in compression it will fail. So when it is failing in compression, concrete, you will be having brittle failure. Brittle failure, what it is? It is sudden failure, right? Brittle failure is sudden failure. Steel is ductile, it will give you time, it will elongate, it will give you deflection. लोगों को पता चलेगा कि अरे यार बिल्डिंग टूटने वाला है, let us run. But if you're talking about concrete, it is a brittle failure. All of the sudden आपके सर के ऊपर पड़ेगा and you know what will happen. Concrete is quite heavy, it can create loss of life. So what is happening? If you are providing more steel, then there won't be any deformation, and only chance of failure is by compression failure. And while this compression failure happens, obviously brittle failure हो जाएगा, suddenly your building will collapse and आपको अरेस्ट कर दिया जाएगा because you have designed such a फालतू structure. So over reinforced structure we should never design as per LSM. Okay, limit state method में over reinforced structure allowable ही नहीं है. So only thing what you have to design is for under reinforced, so that my structure will be safe. समझ में आ गया concept? Everything is clear in your mind, right? If you have any doubt, ask in our target IES group. हमारा जो WhatsApp group है target IES वाला, उसमें पूछ लेना, I will definitely clear your doubts. So let us see all the concepts whatever I have taught you right now, right? And this XU value is also very important. Calculation of XU value is very important. There are three important problems which can be arised. The first one is calculate the XU, that is the neutral axis depth from the top fiber कितना है. Second one is amount of steel required for, he will give you a loading. For this loading कितना steel आपको provide करना है. Second one. Third one, how much is the moment of resistance? What is this moment of resistance of the structure? Let us try to understand. So whenever you are loading in structural analysis में हमने क्या पढ़ा था? There will be a beam and you will be loading, and because of the loading there will be moments generated, right? Because of this loading there will be moments generated all over the structure, आपको पता है. So that is your applied moment. You are applying certain load and because of that these moments are being generated. So that is your applied moment. So on which this applied moment are acting? They are acting on a beam, right? On some structure. Let us say that is your concrete structure. So this whatever structure you have, it has certain resistance to this moment, right? It has certain resistance to this moment. This is called as moment of resistance. Okay, it is moment which could be resisted by this structure. If your applied moment whatever it is there because of your loading is more than your moment of resistance, the structure will collapse. Common sense की बात है, it will fail. If your moment of resistance is more, okay, ये कुछ ज़्यादा ही resist कर सकता है. Let us take it can resist 100 kilonewton meter and you are applying the load such that the maximum moment you are being generated is only 20 kilonewton meter. Obviously this structure can easily take, it will be safe, right? So these three things are very important: calculation of XU, calculation of AST, calculation of moment of resistance. These three problems generally come, and after this module, right, I hope you will be easily able to score 2 marks. Okay, score 2 marks in your gate because this is a very repetitive question to calculate MR, AST or XU. And ESC may be short question hai. In ESC also I cannot imagine a paper without asking any three of this. Okay, so very high weightage chapter. After this module, short 2 marks in gate or ESC. So let us, wasting any time, let us go into today's concept, which is singly reinforced rectangular section. So what is singly reinforced? If the reinforcement is provided at only one side, which side? Compression side or tension side? Obviously tension side पे compulsory रहना चाहिए. So if you are providing only a tension zone, we will be calling it as singly reinforced section. And what is position of neutral axis? See, position of neutral axis कहाँ से measure करोगे? Always from the compression, the topmost compression side you will be measuring your neutral axis depth. So coming to neutral axis depth, how you will be measuring? Obviously the strain diagram will be linearly varying. So you have to use similar triangles, A wala, and you will be finding out what is your XU with respect to your effective depth D, right? बस similar triangles आपको use करना है and you will be getting your XU value just like how we have done in the last module. Very simple. Within 2 steps you will be getting that, right? And what will be the maximum compressive strain in concrete? 0.0035. And what is the minimum strain which you have to have in your steel to get maximum amount of stress? That is 0.002 plus 0.87 Fi by ES. Why I am calling it as minimum strain? Because यहाँ पे तो मैक्सिमम स्ट्रेन मैंने कहा था, बिकॉज आफ्टर दैट, आफ्टर यू आर एक्सटेंडिंग मोर देन दैट 0.0035 स्ट्रेन से ज्यादा अगर एक्सटेंड करोगे कंक्रीट टूट जाएगा, concrete cannot take it. But whenever I am talking about steel, you want to extend it, it will go on extending because it is a ductile material. Steel क्या है? Ductile material है. So you will not have maximum strain in it. वो तो extend करता ही जाएगा. If you are constructing some structure, वो तो कुछ इस तरह extend कर जाएगा. Deflection it will give up to this extent. But obviously we have our limits of serviceability also, right? Deflection ज़्यादा रहना नहीं चाहिए. So we are not taking that much amount. Okay, we never calculate maximum strain in steel. Always it is minimum strain to be on a safe side. If you are applying this minimum strain, you will be reaching this maximum stress. Okay, you will be reaching this maximum stress of 0.87 Fi. So itna, that means if you are reaching this much amount of strain, the entire steel is using its maximum capacity. Okay, every inch of your steel is properly being utilized. इसका मतलब ये होता है. I hope you got the concept right. Everything is clear, crystal clear. समझ में आ गया concept. And this is your stress diagram. I hope you remember it. Corresponding to your strain, you will be getting your stress diagram something like this. So let us try to understand how much stress will be there. Once again, this is your strain diagram and this is how your stress diagram looks like. Let us be very clear. If this is my 0.002, यहाँ तक क्या रहेगा? पैराबोला रहेगा. यहाँ तक क्या रहेगा? पैराबोला रहेगा. And top portion, what is the maximum strain here? 0.0035, right? Here it is 0.0035. Up to this, it is a rectangle, right? It is a rectangle plus parabola combination. This depth how much? Obviously you can see, right? Up to 0.002. यहाँ पे 0.0035. So this should be 4/7 XU and this depth is 3/7 XU. ये जो यहाँ पे डेप्थ बन रहा है that is 3/7 XU. 3/7 XU. Very clear, right? So once you get your XU, you can find out what is the area of your rectangle, what is the area of your parabola. But no need, I have told you the combined area कितना रहेगा? 0.36 FCK XU, right? The area of your stress diagram is 0.36 FCK XU. And here in tension zone corresponding to this, okay, corresponding to this, see, I have told you only steel will take your tensile forces. So once you come below your neutral axis, यहाँ पे जो concrete रहेगा, it is not taking any stress. We are assuming the entire stress is being taken by what? By steel. So in your steel zone, you will be getting a line like this corresponding to the stress. How much will be the stress? If the strain value is greater than 0.002 plus 0.87 Fi by ES, the strain value possible will be only one thing, 0.87 Fi. Okay, 0.87 Fi. End of story. So this is how your stress diagram looks like. Strain diagram linearly varying up to the center of your steel bars, you can say, and then you will be having your stress diagram something like this, some stress diagram like this. End of story. स्ट्रेन डायग्राम, स्ट्रेस डायग्राम समझ में आ गया ना? ये तो लास्ट मॉड्यूल में भी हमने देखा था. दिस वाज जस्ट लाइक कंटिन्यूएशन बिकॉज आई हैव टू रिपीट इट मल्टीपल टाइम्स टिल यू गेट एडजस्टेड इन योर ब्रेन कि ये कॉन्सेप्ट सिंपल है, बहुत सिंपल है. और एल्स व्हाट यू विल बी फीलिंग इज आरसीसी इज अ वेरी डिफिकल्ट कॉन्सेप्ट बिकॉज आई कैन अंडरस्टैंड व्हेन आई वाज इन इंजीनियरिंग ये सब्जेक्ट इतना बुरा पढ़ाया गया था कि आई ऑलवेज फेल्ट आरसीसी इज अ वेरी डिफिकल्ट सब्जेक्ट. I always felt RCC is a very difficult subject and I used to leave it. Even when I was preparing for examinations, first year I left RCC. मुझे आया ही नहीं था दिमाग में पढ़ने के लिए because it is so lengthy and so difficult to understand. Whenever I open the book, it is AST, it is XU, MR, and I never used to remember this such a big formulas. But then I realized you don't have to remember any formula. दिस इज अ प्योर कॉमन सेंस. अगर आप भूल भी जाते हो एग्जाम में डिराइव कर सकते हो इफ यू रिमेंबर द बेसिक कॉन्सेप्ट. 4-5 बेसिक कॉन्सेप्ट याद रख लेना, सारे चीज आपको याद रह जाएगा इन दिस सब्जेक्ट. Such a simple subject. I hope you are getting it right. I hope you are grasping the concepts of RCC after the first chapter, second chapter, limit state method जो complete किया है हमने, introduction जो complete किया है. I hope you are feeling RCC is easy, right? So I took help from some of my friends who made me understand what are the concepts of RCC and what I am explaining you today. So after that I felt RCC is a फालतू subject. यार सबसे easy subject है ये. And even today I am working in RCC related field only. Okay, so now coming to these concepts, let us try to find out what is XU. It doesn't matter whether it is balance section, over reinforced or under reinforced, but over reinforced section is gone. Over reinforced structure is not acceptable in limit state method. So whether it is balance section or under reinforced section. So how to get your neutral axis? Neutral axis कहाँ रहेगा? See, neutral axis will be where I can just use a simple common sense, that is it will be where my compressive forces will be equals to my tensile forces. I will equate my compressive force and tensile forces and I will be getting my XU. Okay, to get my position of neutral axis, what I have to do is I just have to equate my compressive forces equals to tensile forces. That's it. तो मुझे क्या आ जाएगा, मेरा न्यूट्रल एक्सिस डेप्थ आ जाएगा. So what is my compressive force? Let us try to understand. My stress diagram is something like this. My stress diagram is something like this, right? And this area is how much? 0.36 FCK XU. But this is, as this is, let us say this is the last section, we have to take for the entire width, right? I hope you are getting it. We have to take the stress for entire width. So total stress, total compressive force chahiye. How do we will be getting? You have to multiply it with width of section. As simple as that, right? So just multiply with width of section. Let us try to understand. Diagram yahi pe hai. So if you have some body, so let us take some body like this. Okay, so ये जो end section पे बनता है, so on this you have something like this. If this width is B, then obviously what you have to do, you have to take this as your compressive force, right? Because the original body is 3-dimensional. आपको area मिला है, it's not volume. To get volume, you have to multiply with one more dimension, the width of your rectangular section. I hope you are getting it right. So what I am doing is to get my compressive force, my area of the stress diagram into the width, so that I will be getting the exact compressive force whatever is acting on this body. I hope you get it. So my compressive force is 0.36 FCK XU into B, width of section. Very clear. And यहाँ पे in steel, what is my tensile force? Tensile force, what is the stress you will be having in balance section or under reinforced section? Because I hope you remember it, right? Idealized stress strain curve, it was something like this. It doesn't matter, once you reach this much amount of strain, 0.002 plus 0.87 Fy by ES for high yield strength and only 0.87 Fy by ES for Fe250, what will be the stress? It will be 0.87 Fy. 0.87 Fy. So my tensile force will be nothing but 0.87 Fy. This is the stress. This is stress value. To get tensile force, how to get force from stress? What was stress? Stress is nothing but force divided by area. To get force, what you have to do? Force, you have to just multiply stress into area. So what is this tensile force related to? It is related to steel. So what I have to do? I just have to multiply with area of steel. So just multiply to get tensile force, the tensile stress of my steel into area of steel. End of story. So you know the compressive force, you know the tensile force. If you are equating these two for balance section and for under reinforced section, both 0.36 FCK XU into B is equals to, this is my compressive force and this is my tensile force, 0.87 Fy AST, tensile force. Just equate, आपको क्या आ जाएगा? XU is equals to 0.87 Fy AST divided by 0.36 FCK into B. So this is your depth of neutral axis. The axis where there is no compression and no tension from top of your beam, that is your neutral axis, and it is at the depth of 0.87 Fy AST divided by 0.36 FCKB. Please make a correction. Position of neutral axis यहाँ पे लिख लेना clearly, balanced and under reinforced. Both cases under reinforced. Both cases you will be having the position of neutral axis here. नाउ यू कैन आस्क मी सर आपने तो पढ़ा दिया है यहाँ पे रहेगा, बट व्हाट अबाउट ओवर reinforced? Because in over reinforced what is happening, let us try to understand. Same diagram. In over reinforced you are having more amount of steel. So let us draw our stress strain diagram, how it will be looking. Idealized stress strain diagram like this, and this is corresponding to my design stress 0.87 Fi, right? 0.87 Fi. If I have over reinforced section काफी over reinforced है, then obviously my strain value will be less, right? It will be less than minimum strain what should be available. Minimum strain कितना था? It was 0.002 plus 0.87 Fi by ES. So the strain whatever you are getting for over reinforced is less than this much amount. So you are getting strain here itself. So आपका maximum stress कितना रहेगा? It won't be 0.87 Fi. So you will be getting the stress less than 0.87 Fi. So just give me a second. You cannot literally use this formula. You cannot literally. Sorry, video struck हो गया था. What I was saying is, see, this is your strain and this is your stress, right? So strain, it won't be reaching this much amount because it is over reinforced. Strain कम रहेगा. Let us say your strain value is only this much and corresponding stress. So obviously ये कितना रहेगा? It should be less than 0.87 Fi, right? So we cannot literally use this formula. Just give me a second. क्या हो गया ऐसे? See, let me stop this video here because it went quite lengthy, right? So कुछ problem दे रहा है computer. So what I will do is I will stop this video, but I hope you understood, right? So we cannot use this much amount of stress. We cannot use 0.87 Fi in this formula. We have to use something less than that. How much? We'll study in the next module. In next module, we will continue and study this topic. I hope you have enjoyed it, right? If you have liked this video, do like this video and do subscribe to our channel. Have a nice day. Let us see in next module.